Download this code from codegive.com, link in the description below. ms10-087, Microsoft Office RTF Parsing Stack Overflow Vulnerability, a deep dive. The ms10-087 vulnerability is a classic stack-based buffer overflow found in the way Microsoft Office applications, specifically, certain versions of Word, handle rich text format, RTF, files. Exploitation can lead to arbitrary code execution, making it a critical vulnerability. This tutorial will explore the technical details, explain the root cause, demonstrate a simplified vulnerable code snippet, and discuss mitigation strategies. Disclaimer: this tutorial is for educational purposes only. Attempting to exploit this or any vulnerability without proper authorization is illegal and unethical. 1. Understanding the rich text format, RTF. RTF is a document file format developed by Microsoft for cross-platform document interchange. It represents text and formatting instructions using ASCII characters encoded within curly braces. RTF files contain control words, backslash followed by a keyword, example \RTF1, and control symbols, backslash followed by a single character, example \PAR for a paragraph break. These control words and symbols define the formatting, fonts, colors, and other aspects of the document. Parsers interpret these control sequences to render the document's visual representation. 2. The ms10-087 vulnerability, Stack Overflow. The root cause of ms10-087 lies in inadequate bounds checking when parsing certain RTF control words. Specifically, the vulnerability affects the parsing of embedded objects within RTF files. When the parser encounters a specially crafted RTF file containing an overly long string associated with an embedded object, often related to the \JData control word, which specifies the data for the embedded object, it can copy this data to a fixed size buffer on the stack without proper size validation. Because the data written to the stack buffer exceeds its allocated size, it overwrites adjacent memory locations on the stack. This includes the function's return address. By carefully crafting the overflow data, an attacker can overwrite the return address with the address of malicious code, shell code, that they've also placed in memory, example as part of the same RTF file. When the vulnerable function returns, it jumps to the attacker-controlled address, executing the shell code. 3. Simplified vulnerable code example, illustrative, not the exact Office code. This example is a highly simplified representation of the vulnerability. It demonstrates the core principle of an unchecked buffer copy on the stack. It's crucial to understand that the actual Office code is significantly more complex. Explanation asterisk. Asterisk parse underscore object underscore data asterisk. This function takes a string as input, data. It has a local buffer of size buffer underscore size, 256 bytes. The strcpy function copies the input data into the buffer without checking if the length of data exceeds the size of buffer. Asterisk main asterisk. This function creates an RTF-like string in RTF underscore data. It searches for the starting point of the object data using str. If found, it passes the extracted data to the parse underscore object underscore data function. How the overflow occurs asterisk. The RTF underscore data contains an object data string that is much longer than buffer underscore size. When strcpy is called, it continues writing past the end of buffer on the stack. This overwrites adjacent stack variables, including the return address of the parse underscore object underscore data function. To compile and run this code, for demonstration purposes only. 1. Save it as overflow.c. 2. Compile using a C compiler like GCC, GCCO overflow overflow.c. 3. Run it, /overflow. Expected result *. The program will likely crash, potentially with a segmentation fault, because strcpy overwrites critical stack data, like the return address. This demonstrates the basic principle of a stack-based buffer overflow. In a real exploit, the attacker would carefully control the overflow data to overwrite the return address with the address of shellcode. Important notes about this simplified example ***. No DEP/NX bypassing **. Modern operating systems employ data execution prevention, DEP/NX, which prevents code execution from memory regions marked as data. This example doesn't address bypassing DEP/NX, which is a crucial aspect of real-world exploits. Techniques like return-oriented programming, ROP, are commonly used to bypass DEP/NX. No ASLR bypassing *address space layout randomization, ASLR, randomizes the memory addresses of key components like the stack and libraries. This example doesn't handle ASLR. Exploits often involve information leaks or other techniques to determine the memory locations needed to execute shellcode. Simplified RTF structure The RTF data is heavily simplified for clarity. Real-world RTF files are much more complex. Illustrative, not exact. The strcpy function is used to illustrate the unchecked copy. The actual vulnerable function in Microsoft Office uses different, but still flawed, data handling routines. Compiler optimizations Compilers can sometimes optimize away seemingly vulnerable code, especially if it's not used. Turning off optimizations, O0, might be necessary to observe the crash reliably. 4. Real-world exploitation, conceptual outline. Exploiting ms10-087 in the real world involves these general steps. 1. RTF file crafting *. The attacker creates a malicious RTF file containing the vulnerable \JData, or related, structure with an extremely long, carefully crafted data string. 2. Shellcode injection *. The attacker includes shellcode, machine code designed to perform malicious actions like opening a reverse shell or downloading malware, within the RTF file, often encoded within the \JData section. 3. Return address overwrite *. The attacker calculates the precise offset needed to overwrite the return address on the stack with the address of the shellcode. This may involve fuzzing to determine the exact offset and understanding the stack layout of the vulnerable function. 4. DEP/NX and ASLR bypassing *. This is the most challenging part. The attacker must use techniques to bypass DEP/NX, example ROP, and ASLR, example information leaks, to ensure that the shellcode can be executed correctly. ROP involves chaining together snippets of existing code in memory, gadgets, to perform the desired actions, effectively building a program within the existing code of the application. Information leaks might involve exploiting other vulnerabilities or carefully analyzing the behavior of the application to discover memory addresses. 5. Exploit execution *. When the victim opens the malicious RTF file in a vulnerable version of Microsoft Word, the parsing process triggers the stack overflow. The overwritten return address causes the program to jump to the attacker's shellcode, giving the attacker control of the system. 5. Mitigation and prevention. Microsoft released a security update, ms10-087, to address this vulnerability. Applying this update is the primary mitigation. Other general security practices also help. Keep software up to date. Regularly update your operating system and applications, including Microsoft Office, to patch known vulnerabilities. Enable data execution prevention, DEP/NX. Ensure that DEP/NX is enabled on your system. This makes it significantly harder for attackers to execute code from data regions. Use address space layout randomization, ASLR. ASLR makes it more difficult for attackers to predict the memory addresses needed for exploitation. Be cautious with untrusted files. Avoid opening files from untrusted sources or downloading attachments from unknown senders. Exercise caution even with files from known senders, as their accounts might be compromised. Use antivirus/anti-malware software. Antivirus and anti-malware software can detect and prevent the execution of malicious code. Sandboxing. Run potentially risky applications in a sandbox. This isolates the application from the rest of the system, limiting the damage that can be done if it is compromised. Code review and static analysis. Developers should perform thorough code reviews and use static analysis tools to identify potential buffer overflows and other vulnerabilities in their code. Input validation. Implement rigorous input validation to prevent malicious data from being processed by vulnerable functions. This is especially important when dealing with complex file formats like RTF. Use safe string handling functions, example strncpy instead of strcpy, and always check the lengths of data before copying it into fixed size buffers. 6. Tools for vulnerability analysis. Debuggers, WinDBG, GDB debuggers are essential for analyzing crashes, identifying the location of the overflow, and understanding the stack layout. Disassemblers, IDA Pro, Gidra disassemblers allow you to examine the assembly code of the vulnerable function and understand how it processes RTF data. Fuzzers, AFL, libfuzzer. Fuzzers automatically generate a large number of RTF files with random variations to try to trigger crashes and uncover vulnerabilities. Memory sanitizers, address sanitizer, memory sanitizer. Memory sanitizers can detect memory errors like buffer overflows, use after free, and other memory-related issues during program execution. Hex editors. Used to examine and modify RTF files to craft exploit payloads. 7. Conclusion. The ms10-087 vulnerability highlights the importance of secure coding practices, particularly proper input validation and bounds checking when handling data from external sources. Stack overflows can have severe consequences, allowing attackers to execute arbitrary code and compromise systems. By understanding the technical details of this vulnerability and implementing appropriate mitigation strategies, we can improve the security of our software and protect ourselves from attacks. Remember to always keep your software up to date, exercise caution when opening files from untrusted sources, and implement robust security measures to prevent exploitation.